Assalamualaikum and good morning. My name is Elmeen bin Daud and today I will be presenting my final year project, which is titled Development of Advanced Fraud Detection System with IoT. Below are my details and my supervisor is ASOC Prof. Dr. Muhammad Ishaq Abu Bakar. In this slide, I will explain what is my project, why did I do it, how did I do it, the results and the conclusion of my project. The aim of my project is to develop a fraud detector that works with high range by implementing the IoT. Next, I am also will be making improvement of GSM fraud detection system because nowadays we are implementing the IR 4.0, which is the Internet of Things IoT. And lastly, I am aiming to provide sustainable power source for the fraud detector, which I will be explaining later. The project background is to create and to give alert when incoming flood is nearby. The component of the project consists of Arduino, IoT, and ultrasonic sensor, not to mention the voltage sensor, which is the side component. My project is for creating the fastest way to detect flood and warn resident near body of water area. How the project works is by activating the alarm in the Blink app when the ultrasonic sensor detects certain water level, thus causing the Arduino to give signal to user via IoT. My objective is to develop and design flood sensor that can provide alert or signal if flood occur. I am also aiming to design a flood sensor device that can be used to measure water level and warn user faster by Blink app. And lastly, I am developing an updated version of flood sensor that has better interface, which is IoT by Blink app, ultrasonic sensor, LCD display, and lastly the sustainable charging system. The problem statement that sparked this project is all flood detection system is outdated and are inefficient. It needs continuous observation and maintenance, such as removing the battery if the battery is depleted and it is not relevant. Next, the GSM is irrelevant because it involves third-party telco, which causes each SMS to be charged, and nowadays not many people use SMS. And lastly, we are implementing the IR 4.0, which is the Internet of Things instead of GSM. I am showing you the brief history, flood detection system and water level measurement. The first image is the stick gauge, which is used in the early side of the river, or we call the muara sungai. It is continuously observed each 12 hours by a person. Next is wood and chain flood method, a method used by Jabatan Sungai dan Pengaliran Malaysia to measure the condition of the river, and one of the way is by measuring water level using floats. And lastly is the GSM flood detector, which implement the barometer instead of ultrasonic sensor that I'm using, and uses the GSM to alert the user. This is the literature review that I use for my project. The first is by Azid S, Bibia Sharma, B. Raguya, K. Chan, A. Prasad, S. A. Jackie in 2015 in the Journal of Engineering, SMS-based flood level monitoring system. A journal that featured work of several professionals that made a real working GSM-based flood detection system that used barometer and used solar to replenish its supply of battery. This research is my reference to GSM flood monitoring system that I am aiming to improve. Next, I also refer to a research by Lin Wen Tak from UMP that uses moisture sensor instead of barometer because it uses FM radio transmission that is very unique to me, and the device is very reliable. And lastly, I am also referring to LIMTH as a reference to where I should put my flood detection system because it specifically mentioned where we should put a water level monitoring system for better result. The feature of my project is, first I use the Arduino Uno as the microcontroller for computing the codes and implementing to the output. I use two input, which is ultrasonic sensor and voltage sensor, and my output is Wi-Fi module and buzzer. Not to mention the micro hydro generator, which I use to replenish my battery instead of replacing it for several days. There are several tools and tag that I have used, but I will be highlighting one tag that I am specifically using, which is the Blink app. The Blink app is an IoT app which uses smartphone instead of computer. The Blink app can only be accessed by using smartphone, which is more reliable than IoT Gecko because by using smartphone we have faster detection system. This is my block diagram that I use to create the project. It begins by implementing the input from two sensors. The ultrasonic sensor detect water level and the voltage sensor detect the voltage level inside the battery. From the two sensors, the Arduino will compute and tell the Blink app what is the voltage level of my battery and when to give notification to the Blink app. This is the flowchart of my project. If the water level is low, it will ignore and get to the next coding to check if the water level is medium. If the water level is medium, it will send notification, but not a serious notification. Lastly, if the water level is too high, it will send a notification that states the water level is too high. The user will need to evacuate the house. This is the circuit diagram of my project. Please note that this is only reference for my pin assignment because in the Proteus there are no ESP library and my coding starts with implementing the ESP to the Arduino. Therefore, without the ESP library, we cannot do the simulation. This is merely just the pin assignment. We can see the voltage sensor, the ESP8266 and the ultrasonic sensor connected to the Arduino. The voltage sensor is connected to the analog input because it gets its input from the battery, which is an analog value instead of digital. And the ultrasonic sensor and the ESP is implemented on the digital output because it only needs digital output, which is 0 and 1. This is my completed circuit. You can see the Arduino, the place where I attach the battery, and the voltage sensor, the ESP8266. And on the right, you can see the micro hydro generator that connects to the power input to recharge the battery using the water current. And after closing the casing, this is what my project will look like. On the bottom is my ultrasonic sensor. I have sealed the casing completely using silicone sealant so the water cannot enter. I have also removed the LCD display because it has issues of water entering the case, and instead the output from the LCD display is directed to the Blink app, which cut costs. I attach my device to a pole and I submerge the micro hydro generator inside the bottom of the river, and I observe the output from my house. And now I will present my result. Based on the water level, the alert will start at 2 to 3 meters, and the high priority alert will start at less than 1 meter. Next is the error percentage of ultrasonic sensor connected with my Blink app. As you can see, the percentage of error is around 1 to 2%, except for the 2 meter, which I think the internet connection is bad, and I get 18% of error. This is the Gantt chart for the planning of my project, and I have followed the Gantt chart when finishing my project. From week 2 to 8, I did the progress and project report, but from week 8 to 13, I stopped doing report because I want to focus on my hardware. Then on week 13, I started again the project report to finish the report. From week 14 to week 17, I did the presentation, and on week 17, I did the report submission. From week 1 to week 14, the logbook was written. I will now demonstrate my product. This is the micro hydro generator, and I have replaced the battery because it fried my Arduino, and I have to replace the Arduino too. Instead of using that, I am using the power bank and connect to the Arduino inside. I will now open and show my wiring. Excuse my messy wiring, but the product seems to be working perfectly. There is my ultrasonic sensor, my voltage sensor, my Wi-Fi module, and my Arduino. As soon as I connect the power supply, you will hear the buzzing that indicates the Arduino is initializing. The device will then connect to the hotspot that I will show in the following screen capture. The hotspot is now connected, and now I will demonstrate how the ultrasonic sensor works by using the sound of the buzzer. You will hear the buzzing as I get my hand close to the ultrasonic sensor. This also indicates that the Blink app is receiving notification of flood. I will now display what happened in the perspective of the Blink app. Waiting for the device to connect, and there you can see it sent a notification. We will do it one more time. Waiting for the device to reset. This may take a while because the internet is quite slow tonight. Okay, the device is reset. I will put my hand one more time. And there you go. That is my demonstration. Thank you for watching. Based on the experiment, I have obtained few analyses. Firstly, the expected result from FYP1 is fulfilled. Next, I have analyzed that the ultrasonic sensor, water level and voltage sensor Arduino can be synced with the Blink app perfectly. Next, I have managed to get a fast and real water level notification from the Blink app via IoT. I also managed to cut costs by removing several devices such as LCD display and buzzer. Lastly, I made my project a sustainable self-charging system by adding the micro hydro generator that replenished the power of my battery using water current. Based on my experiment, I can conclude that the excellent and the best way to achieve my result is by assessing the problem faced by previous flood detection system, which is the GSM, and the project was successful and the objective was achieved. Below are my achieved objective. I have designed and developed flood sensor that can provide alert and signal if flood occur in real time. Next, I designed a flood sensor device that measure water level and warn user faster than the GSM. And lastly, I have developed an updated version of flood sensor that has better interface, which is IoT, ultrasonic sensor, and also the sustainable charging system. For the recommendation of future development, I would suggest adding extra antenna because the flood detector will be put in the river estuary, or in Malay, muara sungai. Therefore, it will be hard to get any internet connection. But with the help of extra antenna, it can manage to send notification quite well. Next, using custom-made case or better sealant, because even when I seal all the holes, somehow the water managed to get inside. Next, adding GPS system, because when flood occur, the device will definitely be washed away. Therefore, we need to locate back the device using GPS system. And lastly, using micro hydro generator with higher efficiency, because I use a cheaper micro hydro generator that can generate only few watts of power and is not efficient. I would suggest using a micro hydro generator with brushless generator that has lower friction. That is all. Thank you. And if you have any question, please ask me.